So if you have any questions from previous classes or previous sessions, please let me know. We will straight away go to today's class in continuation to the last class about threads and multi-threading. And today, after this class, we'll be having the biological sequence analysis practical class for MSc students. So maybe we can have some break in between about 10 minutes and then we'll rejoin here in the same meeting link. So if you have any questions, please let me know. Otherwise, I'll start straight away. Okay, if there are no questions, I'll just start straight away. I'll share my screen. Okay, let me go back to the PPT. So like last class, we were seeing about the thread priorities. Like initially we saw in the site from Java Point where we saw how the priority works, but we were not able to like see it clearly how the priority is handling those threads. So as we saw, what is a thread is a sub process which is happening to run a massive task. So here in this last example, what we saw is we created a clicker class which will increment once whenever the class is like initialized or called with the run function. So when we run this with different priorities, we were able to observe the priority or the number of runs that clicker class has run. So this was that example where the priority was set to like equal, but if you know that once priority is changed to high priority, how these threads behave. The one example where we saw is like here we have given our own priorities like an increment of 5, so then we can observe that the runs which the thread has made. So the thread with the priority of 1 has run about 36 I think 36 crores 42 lakhs times. So and then if you observe the thread with 6 priority, so you can see the increased runs or the clickers actually basically how many times the increment has been added to that counter. So that's how these priorities work. So if you want to set any priority, if you think some task I need to give higher priority, then you can give this higher number so that it will be executed more number of times than compared to the lower priority ones. I'll just make it full screen. And then the next concept, which is in part to this threading, is like synchronization. So what we mean by synchronization? Can anyone tell what is synchronization? With any example? What strikes your mind when you think about
synchronization? Is like coordination between two or more things.
Any
like,
example?
Eye-hand coordination.
Eye-hand coordination. Okay. Do you think it is synchronized always?
With practice, yes.
Yeah, it can be, but any ideal synchronization which is happening, which you think exists? Anyone else want to give a shot? Any example for synchronization? You can type in chat also. It can be any simple example, any concept which uses the principle of synchronization. Or any two things which happen simultaneously. I don't know. I just thought in mind maybe a simple example. I just now I got it. What is like maybe like the pedals in cycle. One goes down, the other will go up. It is synchronized, but in different directions. You can tell. That's one example. But where we use synchronization concept here is basically when two transactions or two processes are happening, and you want them to be in parallel. So that time you can use the concept of synchronization. So classical example is a bank transaction. Like in a bank, there is like you have an account in bank and then you are withdrawing from the ATM, but it should the same thing or the same amount should be reflected in your bank account also. So it gets simultaneously updated and then it is tallied equally. Like so in the bank machine, some like you are checking the process, how much it is deposited or what is your balance amount. Then you are checking what is the value and then you are updating the balance and then finishing with us. But this is happening from the bank side. But from a customer's perspective, when you go to an ATM, you are entering what's the amount. Then what happens? This process initiates and then it checks what is the amount you have already in your balance, I mean in your account. So then if that amount is not exceeding the minimal balance amount, then your account, like you can withdraw that amount. Otherwise, it will tell you like invalid balance or like insufficient amount present in the account like that. Once, if you satisfy the condition, like if say there is a minimum amount of 500, then if it will check if you have entered the value which is above 500 plus it should not be be false for the condition where minimum amount should be 500 in the sense like balance account I'm saying, but withdrawal amount can be anything. That is also now they have some limits, but it will check minimal amount should be 500. Then it tells that okay, you can withdraw, and then you get the amount, and it is getting deduced in your account as well as like these are happening at 2 points where one thinks that one transaction is happening, like the amount is transferred. It's not really transferred, but just you are getting the money, but in your account balance it is reflected that this amount is reduced or detected from your account. So then once everything is done, then the task is over, like it is closes the task. A current generation example which I can tell you for the synchronization can be blockchain technology. It's same where you have ledgers in the sense you can think of records. So I have a record, you have a record, and then we all have the details of. It's more like a decentralized mechanism. So in bank, all those things which we are seeing in today's world are more centralized. What we mean by decentralized is you can think I have a Facebook account, right? So I have an account and my account details are present in one server. But the same copy of all the data and detail is also maybe like say I have a server, Facebook server in India, I have a copy of all my details in Indian server. But the same exists in US server also. The same exists in European server or Australian server, France. So it has like multiple servers and all of them have a copy of my account details. So if I delete the photo, say for example, I deleted my profile photo. So it is getting deleted from the Indian server. Then it updates all the other servers so that every copy of my photo is deleted in all of the servers. So it's even though I deleted in Indian server, one copy exists in other servers, but when you update in one server, it should reflect. So that concept is called synchronization, where uh, if some transaction or if something happens, it should be shown or it should be updated in all of the servers. And again, this is the same concept how blockchain also works. But again, it is like a decentralized ledger. And I hope people might know about Bitcoins, which works in the same principle, how the transaction happens between two person. You share your wallet or ID, and then you are sending your amount. Then it is reflected in your account or in your wallet, as well as in the receiver's wallet. Also throughout the blockchain network, which is the backbone for the transaction of Bitcoins. So there you have to have a synchronization. Even though one system gets, like say, hacked or corrupted, you will have a copy from the other server or from another decentralized node. So that's how we can have copy as well as prevent other misuse of the data, basically. But again, if you come to banking systems, you may have account in one bank, and that bank alone will have your data. But I'm not sure now how they work, but I think they may have other centralized source where your data gets stored. But again, your branch holds all the information. But when you write or when you tell them, I want to transfer my account to the other branch, they just change your branch to the other branch. When you go back to the old branch and ask, your detail will not be there. Basically, you have to proceed with the branch you requested for shifting. So that's, it's like more centralized, like one data is transferred from one place to another place. It's not decentralized. So the process in which a shared resource, here when you come to programming, it's always the objects, variables, methods, and which is allowed to be used by only one thread at a given time. So here, when we say about synchronization in programming or in multi-threading, what we mean by that is like what the resource which is existing in the program, either it can be a function or it can be a variable, can be used by one thread. Why? Because if another thread utilizes at the same time, what happens is like your transaction gets disrupted. Like I'm depositing money, and as well as say if this happens, I'm going to a bank and then I'm depositing my some amount to my bank, like say 20,000, and simultaneously I have given my ATM card to someone to withdraw that same 20,000. So both are happening at the same time. So what will happen? Which transaction will happen first? So that time you can give priority. That is one thing in the case of threading, and they both are synchronized basically. So even though both happens at the same time, one takes place first and then the next one takes place. Either my deposited money gets added to the bank account or my withdrawal happens. So even though you add your money to your account, it just shows that your balance is this much. Maybe when you just deposit it and then check your passbook, it might show you have 20,000. But again, after like a few seconds, because you have told someone else to withdraw the same 20,000 using ATM, right? So if you check again, it might show, it will reflect that the 20,000 is deducted from your account. So it happens like what to say, like as a procedure, you can tell like one by one. And the different thing which we are using here is by using the keyword synchronized. So synchronized is a keyword which is used for telling that this thread should use all the resources at a time. So an example program where there is a class called call me, and it has a method called call. What it takes as input is a message. The message can be anything, and what it prints with just a square bracket and the message basically. So, and what we are doing is we are making this thread to sleep for 1000 milliseconds. If that is interrupted something, it will throw some error. And like you can print whatever the error message if you want. Otherwise, you can just print the exception. Whatever the exception is. And what we are doing is we are just closing that square bracket. So this is our method, which is void call, which takes a message and then prints a message inside the square bracket, but with a delay of 1000 milliseconds. And how do we implement threads? So one way is to extend the thread class. Other way is to use the runnable interface. So here the runnable interface is being implemented to a class called caller, and it has two variables. You can tell. I can tell like string is also a class basically if you look from a package side, but here we assume that string is a data type and then message is our variable name, and call me is the class basically, our class, and target is our object. So here thread is class, and since this runnable method is interface is implemented, we can use the thread class, and the object is t. And this is a constructor for this class basically. So caller is a constructor. So what it does is it takes the object, which is call me, and an object. It can be, you can pass objects also into function. Okay, it's not necessarily you have to only pass variables or any argument. So in this case, it is considered as like a data type basically. Call me is a data type, but which is a class, and then targ is the object or the variable for this class, and string s is just the name. S targ and then message can be anything. So these are like user defined one. But one thing is you should give whatever variables in the parameter of your function. The same should be followed inside your function definition or description also. So here in this case, what we are doing is we are just assigning this object to the target. So basically, this is the call me object. So this one we are just when you parse a message with, so that it will be taken as a object and it will assign to the target object. Both are objects basically. And whatever you type in case of yes, a string message will be stored in message. Now we are creating a thread for the thread class, which is t is our object. And then to initialize that, you can use the method start. So t.start. And here this is another method which we are overriding. Run is the one which is by default it is there, but since we are implementing the runnable class, we can override that method, and then we can add whatever statements or steps we want to include. So here what we are doing is we want to call by using the object which is called target basically. So target is a call me object, right? So we can use all these methods. So in this case, target.call. Call is a function which is present in this call me class. So it is accessible to my object, right? And messages, whatever message is being sent to the sent via that argument or the constructor basically here, caller. So the synchronization demo, how this works. Now we are in the main section of our program. So what we are doing, call me is our class and target is our object, and then we are creating an object for the call me class. And for caller, we have created three objects. So each object you can find, like what we are doing is we are passing an object called target. Only the message we are like differentiating in the sense like first one we are sending the message hello. Second one is synchronized. Third one is world. So basically what we want to check how synchronization works in this principle. If you don't give synchronization, what happens here basically? So we got, because we did not use anywhere the keyword, right? As I said, synchronize is the keyword which should be used, right? So we did not use that keyword. So if you don't use the keyword and then run this program, what happens? We'll see. And what we are doing is like we are just keeping this object1.t.join. So what happens is this will wait until one gets completed, second one gets completed, and third one gets completed. And if there is an exception, it will just print. So normally what will happen when you are initializing or creating the object, so the caller is being initialized, right? In the sense, the constructor is called. So the constructor is called with the target object and the hello message. So target object and the hello message comes here to this constructor method, and that is like target is equal to target and message is hello basically. And what happens? A new thread is initialized and then it is started. So when you start, run is invoked. So target dot call message is our argument basically. So hello is our message. So call is called. So what will happen here? It will print this square bracket, then the message. What is our message? Hello, and then 1000 millisecond delay. So in that 1000 millisecond delay, what happens? We'll see. So this is how it prints basically. So when you run this program has a lot of things which are missing out in really, but when you want to run the program, we have to correct those errors. So here what happens? A square bracket is printed, right? The message is not printed now. Like it is like the synchronized one is printed now since we have given. Then the world is printed, then the hello is printed, and then the square bracket. Now you can see what is happening here. Each thread is taking its own place or own resource in executing their statements basically here, if you see. So the first message is printed, whatever is printed is like the square bracket, and then synchronize is printed, and then what happens? The square bracket and then the world is printed, and the third one is like hello is printed but the square bracket is outside. This one where we are giving is here basically. So this is that other part of that program. So here the next, I mean the square closing bracket basically. So how we modify that, how we can modify this to make it synchronized is by changing here basically synchronized void call. This part here which is present in this one, so call method, can be changed to synchronized. So if you give synchronized, what happens is like everything is happening like one by one. Only when the first transaction is completed, the second one gets executed. When the second one is completed, the third one gets completed. You can see when you run the program, you can observe that there will be a delay, but the code still waits for it to complete all the task or all the transaction. Transaction in the sense here, you can think of each statements basically here. So each statement gets executed, and then something happened. You are able to see my screen?
Yes, sir.
Okay, I think some power issue. Okay, here. So it gets synchronized and then it prints how we expected it. Like our expectation was to print just the same message, right? Hello, synchronized world. So it should print this way, but okay, 1 second, what we did? Hello world synchronized basically. So here, I think the output should print like hello synchronized world, not hello world synchronization. This is a different program, I believe, because this is sync demo 1, and then this should, if you change in the same program, I mean here, it will print hello synchronized world only, not this way as being shown here. Hello world synchronized will not show. It will show like hello synchronized world, because the previous program is different. Here, these programs, the previous part is different. So it won't print as hello world synchronized. It will print separately, but you understood the concept, right? Like it just takes each transaction, it completes each statement for each thread first, and then it prints the next one. You might ask one question. So why I need to use this synchronized keyword? If I use this join also, it is going to do the same thing, right? In this case, like it will wait for one thread to complete and then it will run the next thread only when the first thread is completed and the second thread is completed, right? So join, what we saw previously, is like it will wait for the first thread to complete and then second thread to complete and the third thread to complete, right? But in this program, when you try running this program and see, you can observe that what we are trying to do is we are trying to run simultaneously certain things where you might not get output which is similar as we expect. Like as we expect in the sense, like it may not show as this way when you use just join alone. It might end up something like this. Since we are providing a delay, so what is the concept of multi-threading is like it want to utilize all the resources by splitting the resources into different threads. So it just uses the other resource while if that one thread is sleeping, in the sense it assumes that it is not alive, in the sense it is just passed. So in that meanwhile, it try to execute other threads. So that is how this concept of synchronization works. Only thing which is new here is the keyword synchronized to use when you want to use different objects to call the same function. Basically here what we are doing is we have just created a different class, but you can directly use the thread object and then call the method or any function which you have created using this keyword synchronized. Any questions, any doubts so far? You can try this program like tomorrow, how this concept of synchronized work, but make sure you create multiple threads and observe how it is working. Okay, let's see some more example about the usage of synchronized. So here, what we are doing is like we have a class called Q, and it has an integer n as a variable or a member, class member, and we have a function which is write. What this write will do, it will print wrote what is the number, and it will return that number basically. So this is our method, and we have used the word synchronized in the sense like we want this to work simultaneously or side by side together basically. And there is another method which is also synchronized method, which returns nothing. What it does, what is the name of the function is, our method is read. It takes an integer as input and it adds to the n in the sense like n is an integer for any object which is belonging to this class basically. So here this refers to the object dot n in the sense. So if you have a q object called qob, so qob dot n equal to the number which you are passing basically. And what it prints as output is it prints read this number, like read colon what is the number, whatever the number it is. So this is a class q which has two synchronized functions which takes an input integer, another writes that integer and returns the integer. So these are the class members and class functions present in the class q. So another class which we are creating, which is called data reader. Now you can keep any name, it doesn't matter. Just for understanding, the same name is kept here. Implements the runnable class. So here what we are doing is we are creating an object for that class, the previous class which we created. That is q is our original class and small q is our object. So this one also has what we are doing is we are creating a constructor for this class, that is data reader, what it takes Q class object basically as an input, and it assigns whatever object. This here refers to the object of data reader class dot Q. So that is this one basically type. So what here we are doing is like we are going a level higher. We don't want an integer to be a data type. We don't want a floating type, or we don't want string type. We are directly using the class itself as a data type here. So the capital Q class is our data type, and Q is a variable. In this case, it is an object also. And this refers to this data reader class. Data reader.q, because this is one of the member of this class, right? So you can assign the value, whatever value. So we are just parsing the same value, right, in the argument. So we are using q as a uniform naming, or a variable name, object name, you can tell, as in this function basically. And another one what we are doing is we are initializing the thread class. So a new thread, and this refers to this object, and you can, as we saw in previous cases, thread method can be initialized without any parameter or with parameter, and with parameter with what is that one, the time or the millisecond. So here what we are doing is we are just initializing that new thread, the object, whatever the object, that is data reader object basically here, and we are just giving the name of that thread, data reader, and start is the usual method to start any threads, and run. When you click start, it will initiate run. So in run we have int equal to 0 until it is while true, then q dot read. So q dot read in the sense q is our object, right, for the class which is reader class, as well as you can tell this q is basically the object of the class q. So dot read is our function. This function, we know, we have seen this function, right? Here it is. So it takes integer input and then it just adds it like I++. So how does this will work? We'll see. 1 second. The same. Here we are using for reading, and this is for writing basically. The same concept. The class name is different here. Instead of here, it is a writer class. The objects are same. Everything is same. Only the name is different. Data writer, and here it will just write q dot write. Here also it should be q dot read only. It's not I++ basically. So q dot write, here it will just read integer and then it will print it. Here it will just write that object integer basically. So this is our main class. It is integer thread communication, you can tell, or comment. So here initializing our object. This is our object. New data reader is our constructor, remember, and the new data writer is our constructor for the two different classes, and it takes object as an argument. So q it is taking as an argument, and it will never stop, right? Because our condition is like it's never going to fail, right? It's just going to run every time. So we're just telling press Control C to stop. It is not going to stop basically. So when you pass this one, basically we have to give a value to that object or the function. So in this case, you can find any number it will print. So here it is showing how the synchronized concept work, like iterate 3493, 3494 until like 3512, and then once this is read, it is writing only these commands, like same. Maybe if you run this one, you will see what is the thing which is happening between these two synchronized classes, like write class and the read class. Sorry, read method and the write method basically. Maybe you can try this program and let me know like how you think the keyword synchronized is working perfectly, or is it working imperfectly. just to show you an example how we can use the synchronized class in different class and then using the same for printing. It's basically here we are just using augmenting, but maybe you can create a account, bank account detail or something. So here, as we see, it is simple read and write. You can think of this as a bank statement. So whenever you are reading, in the sense, you are just checking what is your balance, right? In the sense, and when you do some transaction, so what it does, it will write the transaction detail in the sense like how much is reduced or what is your current balance basically. So when you read, you are checking what is your current balance. That is, say, let's say 3,000 rupees, but you did some transaction. It happens, and then you don't have any idea, right? Again, but in the background, it is reading your amount. Like, say you have balance of 5,000, and then 3,000, same amount will keep, and you have purchased something for 200 rupees. So it read, okay, 3,000 is there, and then uh, debit 200 rupees, so it becomes 2,800. Then it writes to the transaction or the book basically. If you see the passbook or something, it will display you all the transactions. So here same case, but what we did to more simplify it, we just created two methods which will just read and write, and both works in a synchronized manner in the sense like when you read, it reads, and then write, it writes. But if you run this one, you can find it how this works all together basically. Here these are just bits and parts of the program, but if you join, combine together, and then try running it, you can observe how this program works basically. Maybe you can try this. Any questions, any doubts so far? For I hope you understood the concept of how synchronization works, but again, to experience it, you have to try it, run it, or change it, modify, use two synchronized functions, and then see what happens when you call them inside the same method. Or you can simply create a class and create an object, and in the class maybe you can have one integer, or maybe your name and then an integer. So whenever you call the first, you can create an object for the class, and then just initialize the object and maybe just start the thread basically. So initialize one thread for one class and another thread for another class, and then start the threads. So and see, observe what happens when you use the synchronized keyword. Then you can understand like how this synchronization happens between two threads even though they are separate. So what are they aligned, or are they not aligned? You can find out those concepts basically. Maybe I can show you the example from the Java point where we saw previous class, but I'll just show a few things from here. So other functions which exist for synchronization is, one is wait, another one is notify, another one is notify all. So this is basically used for threads which will wait till the one thread is completed, or it will notify when the thread is completed. Otherwise, it will notify all the threads when everything is completed. But you can modify whatever the statements inside this could show. You can add or modify like the print statements or whatever. By default you can change. So here is a synchronized concept here. One second. So here what we are adding newly is like we are adding something which is different from the previous one is. So this is same. The class Q is same. There is no change here. And in this one, we are adding something for this class, that is Boolean flag. So flag is our variable name, Boolean is a data type. So we are just initializing it with false as a default value. And here we are adding a method. So basically, instead of this one, we are going to replace with this one. And same way here, instead of this Q class, this method, we are going to replace it this one. So while the flag is true, basically exclamatory mark flag means true, right? Because uh, not equal to, right? Not equal to this value. So in the sense, not equal to false. So in the sense, it is true. Until it is true, it will wait. If there is some exception happens, it will print the exceptions. And then the flag is just initiated to false. I mean, it is again set to false. If it is set to false, then notify me and then return the n value basically. So the same goes here. The top part is for the write class. The same is being copied for the read class. Only difference is we will just write instead of wrote, we wrote it will be read plus n, and then these things will be saved. Just we want to check or see how this wait notify works. But again, when you see as a static slide or an image of the output, we may not observe anything at all. Like it will show like it read this one and wrote this one, read right. Like it is reading one by one the concept. But when you look, when trying in the terminal, you can observe that it will wait until that one is getting over. Like once this is read, and then it will write it, read, write, and then it will notify in the sense it will just notify us in the sense like here we are not giving any of the additional things, but if you want, you can add the notify options basically, and it will display whatever message you want to type here. Here, from the previous one, we can see how these two are like simultaneously happening in the sense like read and write, like one by one it takes place. It will just writing the numbers. Here the numbers are just arbitrary, but in our program we can specify what number we want to use while initializing the object basically, and suspending or resuming thread. So once you pass a thread or you want to stop a thread, we can use some functions which are there. So what we mean by suspending in the sense like sleeping. Sleep is a temporary stop, right? So that is kind of suspending the thread when it is running iteratively. Iteratively in the sense like when you initialize or when you start a thread, it just tries to execute the functions or whatever the statements you are given inside the run method. You can add functions, you can add any link like a function call, two function call, a function inside a function. So all can be initialized inside this run method. So the left side is the usual one. New thread implements runnable, and we have a variable called name and then the thread object. And we have the constructor for this class, that is new thread, and the same thing like name is the thread name. So basically here the string variable value will be stored as a name, and then the object which is like just initialized the thread object, right? So that is getting here initialized, but with the name of the object as well as the name which we are passing in the constructor method basically, and just we are printing new thread whatever the thread name is, and then we are starting the thread. So when you start the thread, it goes to the run method and then it executes the set of statements which we have defined. So in the run method, what different we have done here is this is the for loop. Just it will just print the name and then the iteration till 0 to 15, and then the thread is stopped for just 200 milliseconds every time during this execution process. And if any exception handle, we are just giving like name of thread which is interrupted because we're just initializing, right? I didn't show the main program, but we'll come to the main program. This is all side parts of the programs basically. So it will print which one is exiting from this run loop basically. Once everything is done, it will print in the next line the name of the thread as well as it will print exiting. So our main class, which is suspend resume, how we want to showcase how resuming a thread works or how to stop a thread. So two methods which is new, I think it will be highlighted here. Yeah, one is the suspend, another one is called resume. So here this new thread is our class here, which we created first. Thread 1 is our object, which is called alpha. Thread 2 is called beta. Okay. And thread.sleep, it just we are just making it sleep for 1000 milliseconds, and then we are suspending the thread 1. So you might ask, like, okay, I created a thread, but nothing will happen, right? But once you initialize this thread, what happens? There is a constructor here, right? So this constructor just starts the thread by its own. You don't have to start it explicitly. So it just starts the alpha thread and then the beta thread. So thread sleep, and we are just suspending the thread 1. In the sense, like, we are just writing that suspending thread alpha, and then again for 1000 millisecond sleep, and we are resuming it. Again, I'll tell the same thing. When you run this program, you can see how it performs. Like, in the sense, like, it will stop for 1000 milliseconds. There will be nothing, just the cursor will blink, and then after that 1000 millisecond, it resumes, and then it prints resuming the thread alpha. But what we are going to see here is we have two threads. So we will see how two threads will behave when you make suspend, when you suspend one thread, and then when you restart another thread, in the sense, like, resume another thread, what happens? That is the thing here we are going to see. So thread 2 is suspended now. Both are initialized at the same time here, right? So thread 2 is suspended now, and we're just suspending the beta thread. And the same case here, both are same. Whatever statement we wrote for alpha thread, the same goes for the beta thread here. And the final one is like waiting for alpha and beta thread to finish, basically. And this is here, we are just giving one after another one. Thread 1 join thread 2, it's going to exception, and main thread exiting. Like, when you create two threads, basically there are three threads, in the sense, one is the main thread, which usually runs without your knowledge. That is the one which starts the program and runs it. And within the thread, main thread or the main program, you are creating alternative threads, which is thread 1 and thread 2, which is called alpha and beta. So how does it shows? Like, we initialized, right? So new thread alpha and beta, and we can see that alpha get 0. Why? Because we suspended the thread basically here after it prints that one. Okay, it goes for sleep, in the sense it is suspended. Then beta is printed, but again within that time beta gets first, and then beta is printed, alpha is printed. So same goes, like, and then suspension happens. Like, this is simultaneously happening, like, in the first initialization step. 1, 2, 3, 4, 5 is printed, and then, like, suspend then happens. So it stops or sleeps. It's in the sense, like, suspending is different from sleep, basically. Sleep will just hold it. Suspending, in the sense, it will just stop it there. But we can resume later. When you, again, I will tell, when you run the program, you can see how this suspend and resume work. Maybe just create a simple program, not this complex. Just with few loops, and then create two threads. Use the suspend and resume alternatively. Maybe you can set a condition also, like, if this, maybe if this is an even number, suspend it. When it becomes an odd number, resume it, like that. You can try that program. Now alpha thread is suspended, right? So what happens? Only beta gets executed here. Then alpha thread is resumed, right? We gave resume option, like, in the sense, dot resume. So when you resume it, why there is a gap here is that is for the sleep, basically. So sleep and the new line character are showing the gaps here. So after this is completed, it goes for sleep. It is suspended, right? Here we suspended the thread. It will print this one, suspending thread alpha. Okay, one second. So suspending thread alpha, it will print, and then it prints the values like because alpha is suspended, right? Then the beta is printed. Then alpha is resumed again. Why we have alternatively we have first we suspended and we resumed, right? And this is a loop, right? This is a loop statement. Yeah, this is a loop, right? It will run this much time, so it gets every time runs basically. So it gets suspended, it gets resumed, and then simultaneously we are giving both. One gets suspended, another gets running, and when it is resumed, it just comes back again. Wherever it stopped, it continues from there. And here both are running together, like 1, 2, 3, 4, in the sense like 11, 12. And beta over, like here where we gave is the resuming beta, and then where we printed the beta thread. Yeah, beta, waiting for alpha and beta to finish basically. I think somewhere we wrote that beta exiting, right? Where it is. Yeah, here basically. So name exiting. So whichever thread first beta is exited, and then alpha is exited, and the main one, which is the main function basically, that is also showing here. So you can try this with simple two thread. Use the functions resume and suspend, and we will see how we can use these two methods to create. You can check with also with synchronized method how this works, and then generally just simply create two threads, run them, some initialize twos together, and then maybe just print maybe some values or some alphabets or some integers just to simply understand how these functions works. So the major things which we saw today are like how synchronized function works, and then I think how we can use this concept of wait notify all we didn't see, but this one which is resume and suspend. So you can try these two functions for tomorrow's class during the practical. And I think that's it for today for Java. I'll stop here. If you have any questions, please let me know. Any questions? Maybe at first this might be a little confusing, but once you try it out, you might understand how this will work. Any doubts, any questions? If there are no questions, then I'll stop here for today, and then we'll see you in the next class. And for MSc, maybe we can join back by 3:10 again here in the same meeting link. I'll just show you some tools. Then we can you can practice those.